Welcome to the channel Maths for Graduates. Today we will derive Cauchy Riemann equation. So let's start. If f of z equals to ux comma y plus iota v x comma y is differentiable at z naught, then it satisfies a very beautiful relation known as Cauchy Riemann equation, and equations are del u over del x equals to del v over del y and del u over del y, this equals to minus del v over del x at z equals to z naught. Okay. Before we start proving Cauchy Riemann equation, let us first recall what does it mean by differentiability of function. Okay. If function f of z is differentiable at z equals to z naught, then limit z tending towards z naught f of z minus f of z naught over z minus z naught, this exists. Okay. Limit exists means limit will be independent no matter what path you have chosen. So this limit will be independent of the path chosen. Okay. So this will be the basic idea for the derivation of Cauchy Riemann equation. Okay. Now what I am going to do here, I will derive this limit in two different manner. First I will approach z naught horizontally and then find limit. Okay. So along this direction, limit z tending towards z naught f of z minus f of z naught over z minus z naught, suppose this equals to limit L1. Okay. And second, when we will approach z naught through vertically. Okay. So in that case, suppose limit will be L2. Since function f of z is differentiable at z naught, so limit L1 and L2 will exist and they will be equal. Okay. Now let's find limit L1 and L2. Now suppose this is point z naught, x naught plus iota y naught, and we are approaching towards z naught horizontally. So suppose if this distance is delta x, then this point z will be z naught plus delta x. Okay. And when z will tend towards z naught, then this delta x will tend towards 0. Okay. Now let's find L1. So L1 is this. So we have limit z is tending towards z naught. So from here we can conclude delta x is tending towards 0. Okay. And f of z, z is z naught plus delta x minus f of z naught over z is z naught plus delta x minus z naught, and this equals to L1. Okay. Now let's solve. So we have L1 equals to limit delta x is tending towards 0, f z naught is x naught plus iota y naught plus delta x minus f z naught is x naught plus iota y naught over this z naught cancels out. So we have delta x in denominator. Okay, now let's solve. So we have limit delta x tending towards 0, and this f of x naught plus iota y naught plus x naught will be f of x naught plus delta x plus iota y naught minus f of x naught minus iota y naught over delta x. Okay, so we can write this equation in form of u and v as limit delta x tending towards 0. So this will be u x naught plus delta x comma y naught plus iota v x naught plus delta x comma y naught minus u of x naught comma y naught minus iota v x naught comma y naught, and in denominator we have delta x. Okay, now separating u and v, so we have limit delta x is tending towards 0, u x naught plus delta x comma y naught minus u x naught y naught over delta x. Okay, and v term is iota limit delta x tending towards 0, v x naught plus delta x comma y naught minus v x naught comma y naught over delta x. Okay, and this is what? This is simple del u over del x at point x naught comma y naught. Okay, and plus iota, and this is what? This is simple del v over del x at point x naught comma y naught. Okay, so we have L1 equals to del u over del x plus iota del v over del y at point z equals to z naught. Okay, now let's find L2. Okay, so for L2 we are approaching vertically towards z naught. Okay, so if this distance is delta y, then this z will be z naught plus iota delta y. Okay, now let's find L2. So L2 is, this is L2. So here we can see z is tending to a z naught. So from here we can conclude that when z is tending towards z naught, then delta y will tend toward 0. Okay, so now let's find L2. So we have limit delta y will tend towards 0, and f of z, z is what? Z is z naught plus iota delta y. Okay, so we have z naught plus iota delta y minus f of z naught. In denominator we have z is z naught plus iota delta y minus z naught, and this equals to L2. Okay, so we have L2 equals to limit delta y is tending towards y naught. So we have, so z naught is x naught plus iota y naught. So we have x naught plus iota y naught plus delta y minus f of z naught is x naught plus iota y naught, and in denominator we can see this z naught cancels out, so we have iota delta y. Okay, now let's write this equation in form of u and v. Okay, so we have limit delta y is tending toward 0 u x naught comma y naught plus delta y plus iota v x naught comma y naught plus delta y minus f of x naught plus iota and y naught will be u x naught comma y naught minus iota v x naught comma y naught, and in denominator we have iota delta y. Okay, now separate u and v term. Okay, so we have limit delta y is tending towards 0 u x naught comma y naught plus delta y minus u x naught comma y naught, and in denominator we have iota delta y. Okay, and plus iota limit y tending towards 0, v term is v x naught comma y naught plus delta y minus v x naught y naught, and in denominator we have iota delta y. Okay, so you can see this iota cancels out, so now we have 1 over iota limit delta y is tending towards 0 u of x naught comma y naught plus delta y minus u x naught comma y naught, and in denominator we have delta y. Okay, and v term is limit delta y is tending towards 0, so we have v x naught comma y naught plus delta y minus v x naught comma y naught, and in denominator we have delta y. Okay, now this is what? This is del u over del y. Okay, so we have 1 over iota del u over del y at point x naught comma y naught plus, and this is what? This is del v over del y at point x naught comma y naught. Okay, now we can write this equation as this 1 over iota will be minus iota. Okay, and we have del u over del y plus del v over del y at point z equals to z naught. Okay, so we have L2 as L2 is del v over del y minus iota del u over del y at point z equals to z naught. Okay, now let's equate L1 and L2. Okay, L1 equals to L2, and L1 is del u over del x plus iota del v over del x, and this equals to del v over del y minus iota del u over del y. Okay, now comparing real and imaginary part, so we have del u over del x, this equals to del v over del y, and del v over del x, this equals to minus del u over del y. Okay, or we can also write this equation as del u over del y minus del v over del x. Okay, so these are the required Cauchy Riemann equation. Now let's summarize the whole lecture one more time. So gist of this video is, if function f of z is differentiable at z naught, then del u over del x equals to del v over del y, and del u over del y equals to minus del v over del x at point z equals to z naught. This is necessary condition. That means when f of z is differentiable, then this Cauchy Riemann relationship holds. Or we can also say that if Cauchy Riemann equation does not hold at point z naught, then this means that function is not differentiable at that point. But if Cauchy Riemann equation satisfied, then this doesn't mean the function is differentiable at that point. Okay, now let me tell you why this condition is not sufficient. Because while deriving Cauchy Riemann equation, what we have done? We have made limit equal in only two directions, horizontally and vertically. And what about other directions? So this Cauchy Riemann equation doesn't ensure the differentiability of the function. Okay, now this video ends here. I hope you have learned something valuable from this video. If yes, then show support by subscribing channel and also press the bell icon. And if you really want to learn this subject of complex analysis, you can buy our handwritten notes, which is specially designed for competitive exams like CSR Net, GATE and more. It is available only for ₹50. This notes contains lots of problems and concepts. So if you're interested, you can contact us through this WhatsApp number. Thank you. Thanks for watching.